Have you ever felt like you're in a foreign country when really you're not? Well, if you're familiar with the phone tapes that I've been putting out, you have a pretty good idea of what the telephone network in the United States and Canada used to sound like in the 1970s and 80s. Well, this series will make you feel like you're in a foreign country because it involves a type of switch that is absolutely unique. And when I first heard it in March 1978, I felt lost. It really was like being dropped down in some strange place that I didn't even know how to get my bearings. But of course, with time and observation, I began to make some sense of it. This is a type of switch which the switchman referred to as motor switch, and it's made by the Siemens company. I found it in Silver Springs, Crystal River, and Salt Springs, Florida, all exchanges of the Florida Telephone Company, a very interesting independent that was known for using a variety of different switches and was pretty unique. Pretty unique is not a proper term, but the fact is that uniqueness is not absolute. For example, the General Telephone Company is unique, but sometimes it uses crossbar 5. That's just like the Bell system, so it's pretty unique. But the Florida Telephone Company is uniquer. Sorry, uniqueness works on a sliding scale. Even New York City, as in unique New York, unique New York, unique New York, is not unique. It's just very unique. So don't give any more crap about the way I say pretty unique, okay? 500 years from now, that error will be corrected, I'm sure, and maybe we'll even reclaim the meaning of the word literally, which has been bastardized in the very way that some of you guys accuse me of bastardizing the word unique. But anyway, this is literally a wonderful set of tapes. That's right, the tapes themselves are jumping up and down with a sense of wonder, just thinking about how they're going to get played for you. God, I could go on and on with this nonsense. So let's get to the important stuff, listening to clicks, dial tones, and busy signals, shall we? Welcome to Grottoes, Virginia, in the Harrisonburg area. I'm on a very long day in a very long phone trip with Dave, and we've just dialed into a nearby exchange of another independent company in New Hope, Virginia. Listen to these clicks.
This is a recording. The number you have dialed is an incorrect number. Please consult your directory or call the operator. This is a recording in New Hope, Virginia. This is a recording. The number you have dialed is an incorrect number. Please consult your directory or call the operator. This is a recording in New Hope, Virginia. This is a recording.
This office that happens to be on N1 Family Carrier shows no signs of being a step office at all. Now, it's real easy to miss this. For one thing, it's a noisy tape because Dave's not covering the mouthpiece according to spastic specifications. But then there's the fact that this is rural Virginia and you just assume that everything is step unless you're paying attention. Anyway, may I direct your attention to two sounds from the previous call. When Dave dials the third digit of the office code, it makes a sound like this. What the? And then he dials an invalid thousand group, and it does this. That's a little hard to pick out of the traffic noise. Here's a similar sound from the next call. Based on what I know now, had I heard that at the time, I would have dropped everything and run over to New Hope. And the reason is that that is the sound that the most exotic switches I have ever encountered in my life make whenever they set up a connection. Apparently it was in the same general category as the rotary system, but this was a different design, and the connections were made by motor-driven switches that very rapidly passed over many contacts, and when they would do that, you could hear it. Well, here's a call from Salt Springs, Florida, to Ocala, in which you can clearly hear the hunting operation. That little groaning noise you just heard is actually the sound of this tiny but exotic switch in Salt Springs, Florida, making a selection to a trunk to Ocala. It's the motor switch running past many terminals and finally arriving on the one that has our outgoing trunk. And this is the sound that I believe we're hearing calling into New Hope. Now in this Florida call, we're sitting on an N3 family trunk to the Ocala step tandem. Let's dial the third digit of an office code that is also a motor switch office. And then when we get to the 1000 group, you'll hear it making its hunting noise as it connects us to intercept.
You have reached a number that is not in service at this time. If you feel you have reached this recording in error, please check the number or dial directory assistance in the area to which you are calling. 904-236.
Anyway, now you can see why when I hear this groaning noise coming from New Hope, Virginia, I groan, because that was an exotic switch. We should have just dropped everything and run over there. Fortunately, when I was in Salt Springs, Florida, I did recognize how important it was to record. Too bad my mom was waiting in the car, and to make matters worse, a sheriff walked out of the convenience store and said this to me: "You walking a little bit too fast, boy." Well, given all that pressure, I didn't record from Salt Springs as long as I wanted to. I probably would have ended up saying something stupid like, "But Mom, it was worth getting arrested. The switching system here is very unique." Yep, my mom would have been disgusted. She was an English teacher. In the motor switch offices, including this one in Salt Springs, there's a register sender on the line from the very first digit, even if the call is only going to end up on a vacant code.
We're sorry. We have a problem in completing your call as dialed. Please check the number and dial again, or ask your operator to help you. This is a recording. 904-685. We're sorry. We have a problem in completing your call as dialed. Please check the number and dial again, or ask your operator to help you. This is a recording. 904-685. We're sorry.
On that last call, we went to vacant code on just 2 digits, each of which was repeated by the register sender. Now, as I listen to this tape, it's a little puzzling because this is actually a semi-dial tone first system, but it sounds like a prepay phone. The call ended, and my phone is still off the hook, and it sounds totally dead, as if this were a ground start line. There seems to be absolutely no talk battery, and yet, here's my hanging up the phone. It almost didn't get any quieter at all. Got to stop the tape now. Yeah, I don't have a very long segment recorded of the phone hung up, but when I pick it up again, you can hear it get a little noisier, but it sounds like the line is mostly dead. Yet it can tell that I picked up because it starts the dial tone process. What you're about to hear is pick up, then the click that cuts battery off completely, and then the dial tone, like this. It's pick up, click that cuts the battery, dial tone. Pretty weird. And then once I have the dial tone, I put in a dime and dial the next number.
have reached a number that is not in service at this time. If you feel you have reached this recording in error, please check the number or dial directory assistance in the area to which you are calling. 904-236.
Gonna stop the tape right there. You know, before we got the vacant code recording, there were 3 register senders in operation. I'm going to play that again. Notice after I dial the last digit, you then have a register sender in the local office, then another register sender still in the local office, and then one in the Silver Springs office that I'm calling. All 3, one after another, repeating that digit, which is vacant.
You have reached a number that is not in service at this time.
The next call is to what I think is a step in the Ocala area via the Ocala step tandem.
You have reached a number that is not in service at this time. If you feel you have reached this recording in error, please check the number or dial directory assistance in the area to which you are calling. 904-245.
What happens next is rather strange. I hang up the phone and I don't get a coin return. Instead, I get another dial tone. When I try to dial something, I get a reorder. Alright, finally I have a fresh dial tone. I tried dialing on the reorder, didn't do anything. I half expected a register sender to repeat my digit over the reorder, but no. So maybe that reorder is the way they handle someone trying to dial without a coin in the phone. Now that I've got a fresh dial tone without a coin in the phone, it did return. Let me try dialing and see whether I get that same reorder. Nope. Anyway, well, here's the next call. Let me back up the tape and play it. Wow, so much going on. After I dialed the last digit, there were 2 register senders in this office repeating it. Then we heard the motor switch in this office making the connection to the Ocala step tandem, and then something in this office dialed a 2-digit code pointing to the office that we're trying to call. So much dialing, and so much of it redundant. The reason there's a lot of redundant dialing is something Mark Bernay will explain in a little bit. From this point on, I tried dialing the rest of the number and we ended up high and dry, but you get to hear the clicks and the dialing in any case. now what? I did a flash, and we've dropped to something that's very quiet and local. The Ocala local tandem trunk is gone now. I'm on something that's real. It's in the office. Let me dial a digit. Well, that definitely did something. Maybe it repeated a digit, but I'm now going to dial an 8, and what will happen is a register sender in this office will repeat the 8, then the motor switch in this office will select a trunk, the trunk will flash, it's an SF trunk, and then a register sender will dial the 8 again. Did you catch all that? And the relay sounds so European. Well, I'm going to dial an 8 again, and then a bunch of 1s, and it's going to turn out that this is going over the operator toll equipment, which has a very American independent sound to it.
For coin deposit. Be 2:15 when they answer.
Okay, let me make sure. What number do you show I'm calling?
881-1111.
Okay, that isn't quite right. I'll call later. Thank you.
Oh man, I wish I could have stayed all day. Let me just play this last part again. There was a string of MFs you heard that was my own number being sent forward, at least the last 4 digits or so. But what was really cool is that we heard a ringtone, followed by the sound of the call going into the operator's board. We hear an outgoing trunk flash, and then very subtly, as if it's a 4-wire circuit, you hear way in the background this string of MFs, and then the operator comes on top of that and says, "1 moment for coin deposit." When I ask her what number she shows, she stops the call and tells me 881-1111. But in fact, that string of MFs that was barely audible is 111-1111.
For coin deposit. Be 2:15 when they answer.
That's all I recorded from Salt Springs. Now here are 2 old phone freaks talking about the British network.
I have to ask you, when you're dialing all that crap, you have to wait for each digit to get pulse repeated?
Yeah, they're storing everyone.
Huh?
Every exchange has storage.
Oh, so I can just sort of dial slow, right? But not, I don't have to wait for all those digits to get absorbed, do I?
No, there's no limit to the amount you can store.
So I could just keep dialing, right?
You can dial normal speed.
You know, the British network of the late 60s and early 70s was mostly step-by-step, and yet they had register senders everywhere. Here, it's not step, and they have register senders, more than one, just on the originating side of one of these offices, and then there's at least one other on the terminating side. So what's up with this? Here's Mark Bernay to explain. And this time he's actually talking about this sort of a switch.
Because the motor-driven switch sometimes has to move more than 10 positions, it sometimes can take it more time than your dial would allow to get where it wants. Like if you're a pretty fast dialer, let's say you dial 365 right away, the first switch might still be trying to find a good trunk between 3 to 3 in the next level in the time you're dialing the next digit. It's not quite as fast as step is. For this reason, they have to have a register sender system that records all the numbers that you dial and then sends them out again one at a time, waiting for the switch to switch over. Like it'll dial 3 into the switch, then it'll wait until that switch tells it it's okay, then it'll dial the next digit and wait for that switch to tell it it's okay, etc. That way you can dial as fast as you want, and if the switches are in a little bit slow mood because they have to hunt quite a bit that day, then the register sender will take over and repeat slowly all the digits that you dialed.
You can then push about okay.
Or not. But the point is there has to be storage and sending at every switching stage because it can take longer than the interdigital time to set up the next leg of the connection.
This register sender combination works on incoming calls as well. If you dial into an office, you're not only dialing into a register in your office, but you're also dialing into a register in the other office. And that register in the other office will then repeat your digits one at a time into its switches. This again is very much different from STEP. In STEP you'll sometimes find director systems in certain places where you are dialing into the director, then the director redials it into the switches. However, that's only for outgoing calls. When a call comes into the office incoming, it always goes directly into the STEP switches. But in this motor-driven, they have the register-sender combinations both ways. You're going into two different register-sender combinations. Your office is receiving the pulses and then sending them out again into the other office. Then the register in that other office is receiving them and sending them out again into its office. So you actually have to go through two different sets of repeating the digits.
We heard that earlier when I showed you a digit being repeated by two register senders in the calling office and one in the terminating. In the next set of calls, we don't hear that, but you can still tell that to these guys, register senders must be really cheap. They're so prolific in this network that I slip and call them pulse repeaters sometimes, but I mean register senders. I just can't wrap my mind around the fact that there could be so many of these fairly sophisticated devices that can actually store and then redial a number of dial pulse digits, not just one. It can store quite a few. And they're everywhere, as you'll hear on some of these calls from Crystal River, Florida, which are up next. This next call has such a soundscape on the rings before the recording. It's really something.
We're sorry, we have a problem in completing your call as dialed. Please check the number and dial again or ask your operator to help you. This is a recording. 904-795. We're sorry, we have a problem in completing your call as dialed. Please check the number and dial again or ask your operator to help you. This is a recording. 904-795. We're sorry.
I don't know what it is about those Autocron announcing systems and this phone company, the Florida Telephone Company, and this kind of a switch, the Siemens motor switch. But that was blastingly loud. And it's the same thing in Silver Springs, which we'll hear later on. You know, that was two digits that went to the vacant code recording. And on the second digit, you can actually hear 3 pulse repeaters. I'm going to play the second digit back again. This is just amazing that you would have 3 pulse repeaters on a call that's ending up on the local vacant code recording. After the dial comes back to rest, there's a pause followed by a tick. That's the first pulse repeater. You don't hear the pulses. Then, if you listen very carefully, you hear a string of very high frequency beeps followed by a click. That's the second pulse repeater. And then the third pulse repeater is more obvious. Now, this is going to happen pretty fast. Again, the first pulse repeater you don't hear. The second one you hear as bursts of a high-pitched tone. The third one you hear is dial pulsing. Ready? and my digit, first, second, or third.
We're sorry.
Yeah, that's how loud it really was. And actually, this tape was a lot hummier than what you're hearing. I spent all day removing the hum, and boy, is that an art. You do it wrong, and all the pulses don't sound right. They ring at the frequencies, kind of like my mouth rings when I hit it. Well, the pulses do that if you don't reduce the hum the right way. You end up hearing pulses that are clicks plus little bursts of harmonics of 60 hertz. And that's not the way the network really sounded. But anyway, here's a call that failed. There are several of these, but they're interesting in this particular system. I don't know if you can hear this, but there's a 360 hertz buzz. Now I'm expecting somebody to say, "An operator, an operator." Here's another fascinating fail. Calls from steps to NX1 usually are dial pulse and have a special trunk that doesn't have a handshake. The NX1's a crossbar system. It needs to get an incoming register on the line before it can receive digits. But calling from a step, it's got extra equipment to handle the fact that the call may hit the line and the subscriber may be dialing without waiting. Here, we're in a dial pulse only environment, as in a direct control step, but this office does have register senders, and so the NX1 takes advantage of that, requiring this office to wait for the flash handshake before dialing. On this call to Homosassa Springs, which is a name I'm glad I'm saying post-speech impediment, you don't hear the motor switch groaning to set up the trunk, but you do hear the flash, like that.
Not in service at this time. If you feel you have reached this recording in error, please check the number or dial directory assistance in the area to which you are calling, 904-628. It is not in service at this time. If you feel you have...
There was an NX1 that didn't let you hear the pulsing, but this. Very typical cut-through sound, especially to the recording. Here's another call that failed, but that doesn't mean it didn't go anywhere. Actually, it seemed to go to two places. First, we get on this strange-sounding T-carrier trunk that has a busy signal in the background. And then eventually, as I keep dialing, seems like a brand new connection gets made. One of the switches up and changes the connection. It ends up going to a reorder again, but through all of it, there are all these motor switch type office sounds. And finally, here's a call to my own number. Ah, Crystal River, Florida, why did I find you toward the end of an extremely grueling trip from Atlanta all the way through South Georgia, with more miles to cover on the way down to Bradenton? Oh, and my mom was in the car. But the good news is that the Ocala office that serves the Silver Springs area, I've been referring to it as Silver Springs. It might be really called East Ocala or something. That office I have good recordings of. In 1978 is the coolest stuff, and I'm going to put that in program 3. It still had old dial tone. The Ocala tandem was still a step, and it had sort of an older way of routing calls, and I demonstrated every route. What's next, however, in program 2 is a May 1982 recording that I made on the fly, again from the East Ocala Silver Springs area 236 motor switch, which at that time had new dial tone, a streamlined and more understandable routing pattern, which I explain, and also the Ocala tandem is a digital, probably a DMS at that time. Still very cool stuff. That's next.